Voyager 1, the iconic spacecraft launched over 45 years ago, is still transmitting valuable information to Earth, giving us the ability to study the universe even without fully grasping what it is. A recent signal sent by Voyager 1 has stunned the scientific community, as it suggests a discovery so profound that it has altered the course of its mission. After traveling more than 14 billion miles from our planet, Voyager 1 appears to be turning back toward Earth. Just 7 minutes before the shift in its course, the spacecraft made a surprising discovery. But what exactly did it find? Could it be a strange cosmic anomaly, potential signs of extraterrestrial life, or something even more astonishing? In this investigation, we'll explore what Voyager 1 uncovered that prompted this dramatic change in direction. To understand this, we must revisit the origins of the Voyager program of the most groundbreaking spacecraft ever built. Their launch might not have occurred at all if not for a rare cosmic alignment. Roughly 6 decades ago, the 4 largest planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, began moving into a rare formation, something not seen since the early 1800s. During Thomas Jefferson's presidency. In 1965, Gary Flandreau, a PhD student in aeronautics at Caltech working at NASA's Jet Propulsion Laboratory, recognized the importance of this planetary alignment. At the time, he was assigned the task of finding the most efficient way to send a probe to the outer planets using just pencil and paper. He plotted their orbital paths and realized that all 4 giant planets would align in such a way that a spacecraft could use each planet's gravity to slingshot to the next. This would drastically shorten the travel time to Neptune from 30 years to just 12. But this opportunity came with a deadline. The alignment would only happen once every 176 years, meaning NASA had to launch by the mid-1970s, rising to the occasion. NASA developed a spacecraft Voyager 1 and Voyager 2 to explore the outer solar system. Thanks to Flandreau's insight and the rare planetary arrangement, the twin Voyagers were launched into space on their historic mission. Voyager 2 launched first on August 20, 1977, followed 15 days later by Voyager 1, which took a faster trajectory. Their primary mission was to study the gas giants Jupiter and Saturn and their moons. However, the probes far exceeded expectations, traveling farther and longer than any other spacecraft in history. They became the first human-made objects to reach interstellar space, exploring regions previously unknown. Together, the Voyagers have journeyed over 12 billion miles from Earth, continually surprising scientists with the data they send. Among their most notable achievements was their close-up study of Jupiter and Saturn's moons, which revealed that these celestial bodies, once believed to be barren like Earth's moon, were unexpectedly active. In 1986, Voyager 2 made history by becoming the first probe to visit Uranus, and 3 years later, it flew past Neptune, a feat no other spacecraft had achieved. To keep the spacecraft operational, NASA began shutting down non-essential systems, like heaters and redundant components, to preserve energy. The goal was to extend their lifespan as long as possible, and it worked. Just when it seemed the missions were winding down, Voyager 1 sent back groundbreaking data. Over 40 years ago, these spacecraft revealed astonishing views of the outer solar system. Voyager 1 arrived at Jupiter in March 1979, just 546 days after launch, followed by Voyager 2's arrival in July of the same year via a slightly different path. Using special filters, their onboard cameras captured over 33,000 color images of Jupiter and its moons. For example, Europa, one of Jupiter's moons, was shown to have deep cracks in its icy shell, evidence of internal activity. Voyager 1 received a gravitational assist from Jupiter, boosting its speed to 35,700 miles per hour, which helped it reach interstellar space. The 2 spacecraft diverged after reaching Saturn. Voyager 1 flew past Titan and Saturn's rings, then left the plane of the solar system. Voyager 2 continued to Uranus and Neptune. At Uranus, Voyager 2 discovered 10 previously unknown moons and confirmed the planet had rings. Shortly after this success, tragedy struck back on Earth Just for days after Voyager 2's closest approach to Uranus, the Space Shuttle Challenger exploded, killing all 7 crew members, including teacher Christopher McAuliffe, later as Voyager. To pass Neptune, it recorded wind speeds of 1,000 miles per hour and flew above Triton, Neptune's largest moon, where it detected volcanic activity spewing nitrogen gas and particles miles into the atmosphere. After these milestones, the cameras were scheduled to be powered down, but astronomer Carl Sagan, a key member of the imaging team, proposed one final photographic mission. On February 14, 1990, Voyager 1 turned its camera back toward the inner solar system and captured 60 final images, including the iconic pale blue dot photo Earth appearing as a tiny speck in the vastness of space. In August 2012, Voyager 1 passed beyond the heliosphere, the bubble of charged particles released by the Sun, officially entering interstellar space. This major milestone was confirmed the following year through published research. Between April 9 and May 22, 2013, Voyager 1's plasma wave instrument detected a spike in electron density, indicating a transition into a different environment. The date of August 25, 2012, was then marked as the official moment of entry into interstellar space. Scientists validated this with electron oscillations and changes in solar particle data. Suzanne Dodd, Voyager's project manager, expressed excitement over this success, and Ed Stone, a key figure in the mission since its inception, emphasized how the data from Voyager was helping scientists understand the interaction between the solar system and the galaxy beyond. In November 2018, Voyager 2 also crossed into interstellar space, continuing the exploration of the unknown regions beyond the Sun's protective influence. But recently, it's Voyager 1 that has once again drawn attention. Even after 46 years, the probe is still operational, continuing to send back valuable information from over 14.7 billion miles away. Then, something unprecedented occurred. Voyager 1 began transmitting unusual signals data that showed inconsistencies in both its course and the information it was receiving. The readings pointed to an unexplained gravitational disturbance affecting its trajectory. This unexpected anomaly suggested the presence of a massive, unidentified object exerting a powerful gravitational pull. This discovery has sparked a wave of speculation and concern among scientists. Could this be a black hole, a rogue planet, or something entirely new? If confirmed, the implications could challenge our current understanding of the universe. NASA has since organized a specialized scientific team to investigate further. They are analyzing the data closely and may reorient Voyager 1 to collect more detailed information. This unexpected turn in Voyager 1's mission underscores how much we still don't know and highlights humanity's enduring drive to explore the unknown. Voyager 1 was originally expected to operate for just 12 years, using 3 radioisotope thermoelectric generators powered by the heat from decaying plutonium-238. Remarkably, the spacecraft has been working for over 45 years. However, NASA estimates that by 2025, Voyager may no longer be able to generate enough power to operate its instruments and communicate with Earth. Even so, something extraordinary happened during a routine communication using NASA's Deep Space Network. After more than 4 decades of continuous data transmission, Voyager 1 abruptly stopped and rotated 180 degrees in action it had never performed before. The maneuver alarmed scientists and engineers, who were baffled by the probe's uncharacteristic behavior. At first, Voyager 1 did not respond to commands, adding to the concern. But it eventually resumed sending accurate data, revealing that its path had been altered by an immense, previously unknown force. Now, scientists are racing to understand the nature of this mysterious object and its implications for our cosmic perspective.